In this lesson, we shall focus on trigonometric equations. We shall solve a wide range of post-examination questions on trigonometric equations and a lot more, and we get started as follows. Right, we begin by actually looking at a general review in terms of what trigonometric equations are about, the idea of the general solution as a very important integral part of the curriculum. Right, in a trigonometric function, there are an infinite number of positive and negative angles that satisfy an equation. Right, so we're dealing with an infinite number of positive and also negative angles that satisfy an equation. This is due to the periodicity of the function. Now, to solve a trigonometric equation where the angle is unknown, you need to find all positive values of the angle. That is, one must determine the general solution to the equation, the sine and cosine function. The sine and cosine functions have a period of 360, and the tangent function has a period of exactly Right, right. So, right. So the sine and cosine functions have a period of 360 degrees, and a tangent function has a period of 180 degrees. So we continue as follows. Okay, let's look at the methods that we actually need to sort of learn. Now, the method for finding the general solution of an equation. What is the method for finding general solution of an equation? Right, simplify the equation using algebraic methods and trigonometric identities. Determine the reference angle, use a positive value. Right, use the cast diagram to determine whether the function is positive or negative depending on the given equation or information. The period of the sine and cosine graphs is 360 degrees. So add k times 360 degrees to each solution and k times 180 degrees to the solution for the tangent. Right, so for the general solution, find the angles in the intervals 0 degrees to 360 degrees, 360 degrees to satisfy the equation, and add multiples of the period to each answer. Right, when solving for the value of x, find the general solution, then substitute k with right, with -2, -1, 0, 1, 2. We always do that all the time when we are obviously now determining the general solution. We always have a perfect chance to substitute those values of k equals -2, k equals -1, k equals 0, and k equals 1, right? K equals 1. So, we continue as follows. Right, so, right, we continue as follows. Right, so, we have the following. Okay, so we actually proceed as follows. All right, now there's something you need to learn also. Now, check answers using calculator. So once again, you need to have your calculator ready to be in a position to calculate and perform calculations. Your calculator becomes very, very important. So yeah, it's a tool that you need. You need to know how to use the calculator for a variety of reasons. We continue as follows. Okay, there are certain things we call the past examination papers practice questions, right? So, for example, we need to have the 2015 March paper 2 question 5.4.1, question 5.4.2. We have the following. Okay, Okay, now for which value of values of x will this particular equation be undefined in the interval where x lies between 0 degrees and 180 degrees? Okay, we're given this particular equation. When is it undefined? It is undefined in two instances, right? It is undefined when we have the denominator equals 0, 2 sine squared x equals 0, and whenever the tangent is undefined. Okay, when we have to the tangent of x, right? The tangent of x is to the sine of x divided by the cosine x, so that it is also undefined when you have cosine x equals 0. Okay, so now that is something very important. Right. We shall have the following. Okay, now what do we then do at this point? Right, so we have to divide by 2 here, getting exactly the sine square of x equals 0. Simultaneously, we still have the cosine of x equals 0.
Why is cos x equals 0?
Okay, that's a good question. Why is cosine x equals 0? Right. Right, so we continue. Why is cosine x equals 0? Right, cosine x equals 0 because we are looking for where this identity is undefined, and obviously it is undefined whenever the denominator is 0. So it's whenever cosine x equals 0. And that is when the tangent is undefined, which appears in the numerator. So there are two instances. It's when we divide everything by the denominator, but also it's when we divide the tangent, when the tangent itself is undefined, and that is when the cosine equals 0. Okay, right. This means that at this point, when sine squared x equals 0, obviously this means that the sine of x equals 0. All right, you can wish to take square roots, etc., both sides to you know, to actually be able to arrive at this. Right, so what you do at this point, you need to look at where the sine is actually equal to 0. When is the sine equal to 0? Okay, you can actually note a reference angle here. What is a reference angle? Right, the reference angle is actually as a result of arc sine 0, and it is 0 degrees. Right, and now also you must be able to get a reference angle here. What is the reference angle? The reference angle is arc cosine 0. Arc cosine 0 is what? It's exactly 90 degrees. Okay, so this becomes sort of the reference angle we need to get. But also we are looking at where we must actually be. We must find all our answers between 0 degrees and 180 degrees. So as a consequence, what are we then having? What are we then having? What are we then having? Right, so now when is the sine 0? Now the sine is 0 if you look at the cast diagram like this. Right, if you look at the cast diagram, the sine is 0 here at 0 degrees, but it's also 0 here. Right. And why is the sine 0 there? Because you know very well that the sine of theta is opposite of hypotenuse. So it is 0 whenever y is 0. When is y 0? Y is 0 on the x-axis. Okay, because any point on the x-axis will have the coordinate. Right. X is whatever, but y is 0. So as a consequence, we actually then have the following. Okay, it then means that would have that the sine is 0 here on the x-axis, meaning it's actually 0 whenever, so you can be able to just take the actual solutions. It's 0 whenever x equals 0 degrees, but it's also 0 here whenever x is 180 degrees. Okay, right. You could say it's also 0 at 360 degrees, but we're supposed to restrict ourselves between right 0 degrees and 180 degrees. So yeah, these are enough. But also now you come here, when is the cosine equal to 0? Right, by definition of the cosine function, the cosine of x becomes adjacent over hypotenuse, and adjacent of hypotenuse in view of the cast diagram, we then have the following. Right, we then have the following. Right, 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 right. Um, um, right, right. We continue as follows. Right. We need to continue as follows. Right. We continue. Right. So we proceed as follows. Now, what do we get then here? For example, because the cosine is adjacent of hypotenuse, okay. So yeah, we have the following here. So now, if you have the cast diagram here, and this is exactly 90 degrees, right? So we'd have that. When is the cosine itself 90? When is the cosine of x 0? Such that x, the reference angle is 90 degrees. Okay, so it is 0. The cosine is 0 because cosine is x over r, adjacent of hypotenuse. Is always 0 on the for any point here. X is 0 and y is whatever. Okay, so now it means therefore the cosine is 0 everywhere on the y-axis. So it's 0 at 90 degrees. It's also 0 here at 270 degrees. So which means therefore that it is the case when x equals what? When x equals exactly 90 degrees. Right, we remember we're looking at between these two, but also it is 0 at 270 degrees. Right, it is 0 to 70 degrees. It is 0 to 70 degrees. And therefore, now as a consequence, we have the following. We have the following. We have the following. Okay, so yeah. All right, as a consequence, then you have the following. So yeah, we have x equals 90 degrees and x equals exactly those. Any question there? So obviously, I mean, there are instances where the cosine is 0 as well. It's 90 degrees, it's also 270 degrees, and other multiples of the 90 and the 270, at odd multiples of 90 and 270, we say. So, but now we're able to see clearly that at this point, we actually have a restriction that all our solutions must be between 0 and 180 degrees, and therefore we're good. Yeah, we're excited. Any question then? Then no.
No.
No question. Okay, thank you. Go on. Right, now we need to prove this identity. We need to prove this particular identity. How do we prove this identity? Right, to prove this identity, you take a side. So you let the left-hand side, which is 2 the tangent of x minus 2 minus sine 2x. Right, minus the sine of 2x, excuse, minus the sine of 2x. Divide everything by 2 the sine squared of x. What is the left-hand side of this? Right, so the left-hand side of this would be that we have this and we want to evaluate this. And to evaluate this, what we do? We actually do the usual thing. So we express everything in terms of sine and cosine, which is sine x over cosine x. And we have here the sine of 2x, and the sine of 2x is what? Is 2 sine x, cosine x. Right, so this is exactly 2 sine x, cosine x. We continue. Right, in which case, therefore, you have 2 sine squared x. Okay, what do we do at this point? So we take this here and we multiply the numerator and denominator by 1 cosine x divided by cosine x. What does this give us? Okay, so cosine is going to cancel this one, giving us exactly sine x minus 2 sine x cosine squared x divided by 2 the sine squared of x cosine x. What is the left-hand side? Right, so in which case, therefore, you have the sine of x. Right, we have the sine of x. In which case, therefore, with the sine of x, we'd have 1 minus 2 cosine squared x divided by the denominator, which is 2 sine squared x cosine x. Okay, we divide then. Right, so the sine is going to cancel one factor. in the denominator. And this gives us exactly 1 minus 2 cosine squared x, all divided by what? By 2 sine x cosine x, like so. Right, so what does this give us? Right, we need to analyze this and check what it gives us. Because what is 1 minus 2 cosine squared x? Right, so 1 minus 2 cosine squared x is seen as what? Right, this can be seen as exactly cosine 2x. Okay, that is one thing you can do. But now let us look very carefully. Okay, there's a 2 here. There's a 2 there. And there's another 2 here. Okay, so now you can factor out these 2 and then have exactly a 1 here, like that. And what does this give us? Right, so at this point, then you'd have exactly the following. Right, so you'd have the 2 canceling. Right, so these 2 is going to cancel with the other 2. And the sign is going to cancel, leaving us with exactly the sign of x in the denominator. And here you're going to be having exactly 1 minus cosine squared. And 1 minus cosine squared by the Pythagorean identity is the same as sine squared x divided by the sine of x cosine x, divide through by the sine, and then we have exactly sine x divided by cosine x. What is sine over cosine? Is 10x. And this 10x is actually the right-hand side. I'm sure this is pretty straightforward. I'm sure this is pretty straightforward. Right. Any observation, any question, any idea, anything you can add or remove? What can we add and what can we remove?
Everything is fine.
Thanks, Noah. Move on. Okay, we move on. Try the next one. Okay, we need to consider the identity given. We need to prove the identity. Now, to prove identities, we always do the following. We always do the following. We let the left-hand side be 8, the sine of 180 degrees minus x times the cosine of x minus 360 degrees, all divided by the sine squared of x minus the sine squared of 90 degrees plus x, like so. Okay, now let's look at these together. Let's look at these together. Right. We continue. Right, so we continue. We continue. Right, we continue. Okay, what do? We need to remember some things here about the cast diagram. What does the cast diagram actually tell us? So if you look at the cast diagram, we're able to take note of the fact that if you have 0 degrees here, 90 degrees there, 180 degrees here, 200, and 70 degrees there, 360 degrees, in which quadrant is 180 degrees minus x. So when you say 180 degrees minus x, you're going back to, you are reducing 180 and we are making it smaller. That takes you back to what we call the second quadrant. If this one is the first quadrant, the second quadrant, the third, and then the fourth quadrant. 180 minus takes us to the second quadrant where the sign is positive. So that obviously you'd have 8, the sine of x. Right, so now x minus 360, in which quadrant is x minus 360? So you need to think about this. Obviously, x minus 360, because it's a negative angle that is involved here, and it actually helps to then say, you can say 360 degrees plus x minus 360 degrees, like so. And you divide everything by actually the sine squared of x minus, okay, in which quadrant is 90 plus? It is in the second quadrant, in which the sign is positive, but Now, obviously, see, if you say 90 degrees plus, you're taking yourself to, you are making 90 bigger towards 180, making, obviously, putting yourself in the second quadrant in which the sign is positive. All right, if the sign is positive there, then obviously, but it changes to its co-function using what you call the COCO. Right, the COCO rule. Okay, the COCO rule dictates co-function changes at 90 and 270, and therefore, this is going to be exactly the cosine. The cosine squared of what? Right, the cosine squared of x, where the sign is positive. Okay, now, what is all this here? So we need to write these, but now we can see the answer is a double angle. It's 10 to x. So that we have 8 sine x, and then it is the cosine of x. We divide everything by this, the following. So you need to remember something here about the double angle formula. The cosine of 2x is the same as cosine squared x minus the sine squared of x. So that now we can just factor out the negative, and then you have cosine squared x minus sine squared x. So we have the following. Right. So we would have exactly 8. We have exactly 8. Right, let's have exactly 4. Just pull out factor 4 from the number 8. Right, if you factor 4 from the number 8, you'll get the following. So let's just do the factoring quickly. Right, so if you factor 4 from the number 8, you then have 2 sine x times cosine x, like so, and you divide by negative. We have seen that cosine squared x minus sine squared x is cosine 2x, and the denominator will therefore be minus cosine 2x. 2 sine x, cosine x. Right, so we know that sine 2x is the same as what? Is the same as 2 sine x. Cosine x is our double angle formula. Okay, right. We continue. Okay, this is sine 2x, cosine 2x in the denominator. And we said that 2 sine x cosine x is the same as sine 2x, so that this is exactly 4 sine 2x divided by minus cosine 2x. Okay? Which is minus 4. What is sine 2x over cosine? Sine over cosine is the tangent of 2x, and this becomes our right-hand side. Any question, anything to add or remove? Any suggestion on this one? And then we'll move to the next one now.
No.
Nope. Okay. Yeah. Okay. We're gonna work together. And so some of the questions you're gonna try. Obviously, I'm just breaking ice. So opening the stage, but yeah, we actually shall manage everything, shall manage every single bit of thing. Right. 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 We continue. Okay, we're to prove the identity, and we've proven the identity because the right-hand side is minus 4, 10 to x. Next question. Right, for which value of values of x in the interval x between 0 degrees and 180 degrees will the identity be undefined? Right, so for the identity to be undefined, there are a couple of things that we need to take into account. What do we take into account? Any form of division by 0. So you have to look at both sides of this. So that would mean that it's when sine squared x minus the sine squared of 90 degrees plus x equals 0. And, okay, the tangent, we said that the tangent of 2x, like the tangent of x, is always the sine of 2x divided by cosine 2x, in which case, therefore, this would be cosine 2x equals 0. So at this point, then, both sides of the equation, we look at the left, is when the denominator on the left is 0 and the denominator on the right is 0. Okay, what do we get here? What do we achieve? Okay, now there are a couple of things you need to achieve, and you need what to actually be in a position to do this. We can perform some reduction here. So we have sine squared x minus 90 plus. We said it's in the second quadrant in which the sign is positive according to the cast diagram. But now we take note of the fact that it's positive, that is, the sign is positive in the second quadrant, but it changes to its co-function, all right? And the co-function is the cosine, right? The cosine squared of x equals 0. Right, and this is awesome news for us. Awesome news for us, because we know that cosine 2x is cosine squared x minus sine squared x, meaning at this point, you can factor out negative, getting cosine squared x minus sine squared x equals 0, negative. Okay, but cosine squared minus sine squared is cosine 2x equals 0, meaning cosine x, cosine 2x equals 0. Okay, let's deal with this. Okay, cosine 2x equals 0, cosine 2x equals 0. Yeah, we're dealing with the same thing here. Okay, this is good news. So, yeah. And then as a consequence, what do we deal with? It means that we just need to solve only one of these. Right, so obvious at this point, when cosine 2x equals 0, what then is this? First things first, we need to obviously find x between 0 degrees and 180 degrees. So get our reference angle, which is arc cosine of 0. And arc cosine of 0 is what? It's actually exactly 90 degrees. Right, and obviously when is the cosine equals 0? And yeah, you would agree that in general, it would be plus or minus 90 degrees there. In general, it would be plus or minus 90 degrees because the cosine is an even function. But now we're interested in only the angles that are between 0 and 180 degrees. In other words, we're interested in the positive angles there. Okay, so we're good. We're good. We're good. We're good. Anything else we can do? Right. So, but now if you take plus or minus 90 degrees, you can then say that 2x is plus or minus 90 degrees plus 360 degrees by k in z. Dividing by 2 means plus or minus 45 degrees plus 180 degrees times k in z. Right, so obviously at this point, what do we do? Right, we would see therefore that x equals what? Right, when k is 0, we choose the answer that is required. When k is 0, x is what? Okay, x is plus or minus 45. So you're going to take only 45 degrees because we don't want negatives. It's only between 0 and 8 degrees, meaning we're dealing with positive angles. K equals 1. K equals 1. When k equals 1 is 180 degrees. 180 minus 45 is what? 135. Yeah. X equals 135. It's okay because it's between 0 degrees and 180 degrees. Right, but now we can't take the plus. We can take if we wish to take the plus 45. So you have 180 degrees plus 45, which is 225. So it's outside this range. So we can take 135. And yeah, if you take any other k, like you take k equals to -1, then you have negative 180 minus 45, which is minus 225. It's outside. If you take k equals 2, then 2 times 180 is 360 minus 45. Okay, it is still 360 minus 45 is way beyond 108 degrees. So yeah, we're good. We're good. But now, I mean, the couple of things you need to take note of that we are dealing with exactly, we are actually solving these particular equations here. And in both instances, I mean, you'd have therefore that x is 45 degrees, x is 135 degrees. So you have both solutions like that. Any question, anything to add, remove, or any suggestion now?
So when you substitute, do you always have to start with 0?
Oh, that's a good question. Not really. You can start with the negative numbers. In principle, because integers themselves are okay, the set of integers it has -3, -2, -1, 0, 1, 2, 3. Okay, so in principle, well, I mean, you can take the negative numbers. Any of the negative numbers is 0, 1, 2, 3. But now, look, there is an issue with the negative numbers. Why? Because if you could choose -1, you have 180 degrees times -1, and then you have minus 180. And already the examiner said, please deal with the positive angles only, okay, between 0 and 180. So this -1 is going to just give us negative angles, which the examiner does not want for this question, you know? Okay, right. Anything else now?
And then when you substitute, let's say you substitute -1,
Yeah.
then how do you know when the other negative numbers are not gonna be suitable?
Okay, that's a good question. Right. Let's say that's a good question. I mean, if we substitute -1, right, and if we substitute -1, right, for example, 180 degrees times -1 is minus 180 degrees. Okay. And so this interval, they're saying for which values of x in the interval this, meaning we're able to see that negative angles are not even wanted. So, but obviously it makes sense to try the -1. Like I tried -1, but I could realize that it's going to give us 180 degrees times -1. It's going to give us minus 180. Even if you say minus 180 plus 45 is minus 135. Okay, so minus 135 does not lie between 0 and 180. So obviously, I mean, it's trial and error. So you just to plug in the numbers and see if you're getting the answers within the specified interval, you know, within the specified interval. Okay. Right. Okay, any question now? Anything
So
else? Yes.
when they're talking about like where it's gonna be undefined, do you also
Yes.
look at the numerator? Like
Yes. So we need to look at both the
if
numerator
if
and
10x is a numerator, that means cos x is also
yes, because x is also obviously considered. Because if
mm,
ever the 10x was in the numerator, you would have to consider the 10x in the what? In the numerator. Because it would actually be undefined at some point. But you see, the rest of the numerator functions or terms here are all continuous everywhere, and also they are never undefined, like the sine and the cosine. So we're good with those. But yeah, the issue becomes only the 10 there and the other denominators as well. Okay. Right. I believe it's yeah.
okay. Thank you.
Okay, that's fine. Thanks now. Okay, some questions you will try. Some questions you'll try. Okay, we move on. Right, let's move on. Now let's look at the exemplar question. Determine the general solution of this equation here. So if you have been given cosine 2 theta plus 4 sine squared theta minus 5 sine theta minus 4 equals 0. Okay, we have this particular equation. And we need to determine the general solution. In other words, in this case, we're going to leave our answer in terms of k. Right, but now it is very important that obviously we are very, very considerate. But there is a giveaway. There's a giveaway. What is the giveaway? The giveaway is we have a double angle formula, and we actually have, terms in that actually involve the sign of theta. So now we need to take note of the fact that cosine theta is equal to what? Right, it's equal to 1 minus 2 sine squared theta. Okay, because that's the identity that's going to work. Because obviously you would remember that etc. You will try some of the problems here, right, to practice along. Right, if you have cosine 2 theta, you can also we also have cosine squared theta minus 1, but now, or the 2 cosine squared theta minus 1. But you can see that obviously we're going to use this one here. We're going to use the one of the sine, so that everything is in terms of the trigonometric sine function, so that we have 2 sine squared theta 4 sine squared theta minus 5 sine theta minus 4 equals 0. Right, so we continue as follows. We continue as follows. Right, so yeah, what do we get here? We just add like terms. We just add like terms. So right, so what do we get here? Okay, we add like terms. Adding like terms means that we have minus 2 sine squared plus 4 sine squared. And this gives us exactly 2 sine squared. 2 sine squared theta. Right? And then we have minus 5, the sine of theta. 1 minus 4 sine theta becomes minus 3 equals 0. Okay, so we're going to be really very objective in the way we factorize this. So we can use the K method. Let K be sine theta, so that we're able to achieve the following. Okay, makes a lot of sense. We're able to achieve the following. We're able to achieve 2k squared minus 5k minus 3 equals 0. Right. Okay. Right. So what do we do now? Okay, we need to factorize this. How do we factorize this? There are a couple of ways of it to factorize this. I know you can look for the factors, but now there's one popular narrative we use. What is 2k squared times minus 3? It's minus 6. Minus 6. 2 times minus 3 is minus 6. We look for the factors of minus 6 that give minus 5. What are those? So we have 2k squared. The factors of minus 6. The factors of minus 6, because 2 times minus 3 is minus 6. The factors of minus 6 that give minus 5. What are they precisely? Right, can you guess those? Okay, because we have minus 6. What are the factors of minus 6? That would give you exactly minus 5 when added together. Right, so now somebody can say the factors of minus 6 can be seen as that, minus 6 times 1. So minus 6 times 1 would give us minus 6, but when you add them up in terms of minus 6k plus k minus 3r equals 0. Okay, yeah, minus 6k plus k would give us minus 5k. Okay, this is one way of factorizing. I know that you can actually, have your own way. And many times you can just put parentheses here and just distribute by trial and error, get your factors right. So now at this point, this becomes k minus 3, like this, like this, like this, like this, like this, like this, like this. K minus 3 equals 0. Okay, let's do this. Let's do this. We therefore have k minus 3, 2k plus 1 equals 0. Right. Okay. We continue. We continue. So what is all this here? Right. So we shall be able to get k equals 3 or k equals minus 1/2. But yeah, but the k is sine. So that sine theta is 3 or sine theta is minus 1/2. Okay. So all right. Now what do we do here? So this one is not applicable because the sine, right, because minus 1 is less equal to sine theta, less equal to 1. Okay, the sine of theta is bounded. It's a bounded function, and therefore it lies between minus 1 and 1, so there's no way the sine can be anything beyond 1. So sine theta equals 3 has just no solution, so it's not applicable this. But now we have this one here, and we get the reference angle. Right, so the reference angle is arc sine 1/2. Reference angle arc sine 1/2 becomes 30 degrees. Okay, remember, you take the positive of that. And now we're going to just look at the fact that we are dealing with this one. So now we are dealing with the fact that we have the sine of x equals minus 1/2. That's the case we're looking at. And the reference angle is arc sine 1/2, 30 degrees. And then, what do we do? Right, so we're going to consider the cast. Right, we're going to consider the cast diagram. And this cast diagram is what we use just to get some answers. But now we have the following. When is the sign negative? Right, the sign is negative in the third and the fourth quadrants. Right, and it's positive in the first and the second, meaning that you're going to deal with this. So x becomes 180 degrees because that's 180 degrees here. This 360 degrees, those are the ones we use. So we use 180 degrees and then we add 30 degrees. We add our reference angle and then we have the period of the sine function, which is 360 degrees. It is a general solution we're looking for, in which case, therefore, our answer must be in the required form. With k. Right, 180 degrees plus 30 would give us exactly 210 degrees. Plus 360 degrees by k in z, right? Simultaneously, this is not all. We found one of the solutions, and we then say this is the case, or we have the other solution. And what is the other solution? The other solution arises when we are dealing with the fourth quadrant, because here we're dealing with the third quadrant. The fourth quadrant will be 360 degrees minus 30. 360 degrees by k in z. So this is 330. 360 by k in z. Like that. Right, any question? Now we're to find a general solution. So we found specifically two solutions. One solution, a set of solutions that operate in the third quadrant at 180 degrees plus 30. But also we have other solutions that operate in the fourth quadrant where we have 330 degrees. Okay, continue. We continue. Next point. I believe there's no question here. Any input, any suggestion, anything different? Maybe you have a different way of doing this now.
No, this is how I do it normally.
Oh, all right. Thanks, Noah. Right, we move on. All right. There are some questions you will do, please. I'm going to give you some. All right, now, let's do this one. This one shall do together. Show that this is that. So you are starting with cosine 2x. It is divided by cosine x plus sine x. What is cosine 2x? Cosine squared minus sine squared. You divide everything by cosine x plus sine x, which is now, okay, this is the actual double angle formula that we're going to use for cosine 2x, because there are like three of the associated double angle formulae for the cosine 2x. Right, in which case, therefore, this becomes cosine x minus sine x, in parentheses, cosine x plus sine x. Right, so we have cosine x plus sine x. Cancel this, getting cosine x minus sine x. All right, obviously we're to show, therefore, that this is cosine x minus sine x, and we've showed that. I always ask if you have a question or anything else. If you have a different suggestion, maybe we think you need to add something, please you comment. Because I know you are the student, so I must give you a chance to share your view on these things, you know. Right, I must give you a chance to share your view on these things. Right. No view now, too easy, right? All right, I'm assuming it's too easy. Okay, now here's another question. Show that this one is 1/2. Okay, show that this actually, show that cosine, okay, let's write this one down. Show that cosine x, which is cosine 2x divided by cosine x plus sine x equals 1/2. Right, show that this is one, you show that this equals 1/2 can be simplified to this. Right. So this is a very interesting one. Right, try this one now and let me know when you're done. Okay. Right. Okay, yeah. Okay, yeah. Please try this one. Let me know when you're done now. And then we're gonna discuss it. Okay. Okay. Okay, yeah. Okay. Okay, so yeah, you let us know please when you're done. Just looking at this one. Show that this one can be simplified exactly to that part. So please obviously let us know when you're done. Let us know when you're done. Right, I want us to discuss this one together. Right, and then when discuss, then we shall see exactly what the examiner's objective was on this particular question. Right, also we'll see exactly what the objective was on this particular question. So yeah, we're good. We're good. We're looking at the 2015 Gauteng preliminary paper. Right, we're looking at the 2015 Gauteng preliminary paper. Right, focusing on paper 2, question 6.2. Right, 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 right. Okay, 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 okay. Right, so we're good, we're good, we're good, we're good. Right, so continue. Right, I want you to actually, obviously, please let us know as soon as you're done, you're done, you're done, you're done, you're done. And then we're gonna discuss exactly what needs to happen. So we're good. We're good, we're good, we're good, we're good, we're good. Right, we're good, we're good. Please let us know as soon as you're thrilled. Okay, and obviously sort of continue to right as you look at 6.2.2. I want us to discuss this one. Right, I want us to discuss this one. Right, yeah, okay, there's a small typo. Whoever typed this one, so this one should be cosine 2x equals sine 2x. So yeah, there was a mistake. This must be an equal sign, this. Okay, so whoever typed it did not type it correctly. Right. How far, Noah? Okay. Okay, you're good. I know you're
So
good.
I
Yes.
multiplied cos x times cos 2x.
Yeah. And you
And
got
then I said,
yes.
then I said over cos x plus sine x equals half.
Yes. Equals 1/2. Uh-huh.
And then I said 2
Yeah.
2 bracket cos x times cos 2x.
Yes.
And then
Okay.
I said 2 cos x times 2 cos 2x over
Yes.
cos x plus sine x.
Yes.
Then
Okay.
it's Then it's 2 cos x
Okay.
times
Okay, can I
2.
just write that one? Okay, you said cosine x, yeah? And you're multiplying the numerator, right? Okay, yeah, this is
Yes.
fine because it's just one discard. Doesn't really matter. There are too many ways of doing this. So you said cosine x, and then you wrote cosine 2x, and you then said all divided by, yeah?
Over cos x plus sin x
Cosine x
equals
plus
half.
sine x equals 1/2. Okay, yeah.
And then I cross multiply
You
2
just
cos
multiplied.
x times
Yeah, so you got
cos 2x.
2 cosine x, cosine 2x, and this equals cosine x plus sine x. Yeah, doesn't matter. There are too many ways of
Yes,
doing
it's
this.
2
Yeah,
cos x times cos 2x equals cos x plus sin x.
okay. 2 cosine
And then,
2. Yeah, okay, like this. Is it like this? Okay.
yes,
Yeah.
yes,
Mm-hmm. And then what did you achieve? And then it became too complicated. Little bit,
yes,
I would imagine.
yes.
Never mind. Okay. Because you would remember something we did before. What did you prove these to be equal to in the
Half.
previous question? Right. We proved it to be, we used the cosine squared minus sine squared x. We divided by cosine x plus sine x. Okay. We used this fact before. And I know that, so it's going to be shorter. I mean, your method is okay because it's going to lead to the answer, but it's going to take some good amount of effort. So you have cosine x minus sine x. You factorize the numerator, and you have cosine x plus sine x. Okay, what am I giving as a hint here? Sometimes you always, in mathematics, always try to use the previous answer. Normally the examiners in the same question, yeah? 6.1, 6.2, etc. So you'd have that, for instance, this one is going to cancel this, and therefore this is cosine x minus sine x. I mean, it tells us that if ever you have the cosine 2x divided by cosine x plus sine x, this will be 1/2. So that you have cosine 2x. What is cosine 2x over this? Right, once again, cosine 2x over cosine x plus sine x is the same as what?
So how did you do it? Which previous question?
Okay, that's a good question. With previous question, it is exactly this one here. It is this one because yeah, we even went through it. So remember that in this question we had to show that, right, we had to show that the cosine 2x over cosine x plus sine x is this, you know, and yeah, so because by dint of that, by dint of the fact that we showed that whenever we have the cosine 2x over that in the previous question, it gave us cosine x minus sine x. So yeah, it's going to be exactly that. It's going to be exactly that. It's going to be exactly that. So we continue. We continue. Okay. Right. Okay. So we're saying that because right now, then it means that in the place of this big thing here, we already know that it is cosine x minus sine x. So it is actually equal to 1/2, like this. And so we are now, this fraction is like simplified, and then, okay, remember that, yeah. This one is only just cosine. It's not anything else. Okay, it is not anything else. It is just like cosine x. Okay, we perform distribution. We perform distribution. We perform distribution. What distribution are we able to perform? Okay, multiply cosine by cosine, and we get cosine squared x minus cosine x sine x equals 1/2. Okay, we get this. And then we can cross multiply. Getting 2 cosine squared x minus 2 cosine x sine x equals 1. Okay, which is 2 cosine squared x minus 1 equals 2 cosine x sine x. Okay, now 2 cosine squared x minus 1 comes with cosine 2x, and this one, 2 sine x cosine x was 2 cosine x sine x. We know that whenever we have 2 sine 2x is the same as 2 sine x cosine x. Okay, so that this one is going to be exactly sine 2x. So that obviously, as I indicated, that whoever said they typed this question did not type it correctly. Show that this cos half can be simplified to cosine 2x equals sine 2x. And we have proven that cosine 2x equals sine 2x. Okay, so any question, any suggestion, maybe you have an input to make, a change you suggest we need to do.
So
Yes.
you changed cos 2x to cos x minus sin x.
Yes. We changed cosine to x to cosine squared x minus sine squared x. Okay. And then obviously this becomes like a difference of 2 squares. Right, and the difference of 2 squares, whenever we have a squared minus b squared, it is a minus b times a plus b in brackets. Excuse. Okay, so that is what we're able to achieve here. That is what we're
Oh
able
yeah,
to
now I see.
achieve. Okay, yeah, that's what we're able to achieve. Never mind, it's this. Okay, that is what we're able to achieve. So yeah, take note of that and see and make sure you're able to understand. Right. Yep. Right, I give you a chance to think about it and also share your view, share your suggestion, and then we proceed. Right. Is it fine? I mean, maybe you think, okay, we need to put it easy. Are we not missing a 2 somewhere? You can answer the question. Maybe are we not missing a 2? Aren't we supposed to have a 3? Or aren't we supposed to square something? Or anything of that sort?
No, it's fine. It looks
Okay,
fine.
thanks. Okay, thanks now. Move to the next one. See, now we have another one. Okay, yeah. Here is the Gauteng question. And this Gauteng question is as follows. Hence, determine the general solution of this equation. Okay, the examiner said hence, meaning that, hey, we need to use something above. And what do we do, therefore? Because we need to determine the general solution of this, which is exactly cosine 2x. We divide everything by cosine x plus sine x equals 1/2. What do we do here? How do we determine the general solution of this? I mean, in principle, we would have to cross multiply and use identities and do many things. But now we already know something because they said hence, so we need to use the question above. What is the question above? The question above
And so you
is
can
that, yeah, we're
cos
going to use
x
this one.
minus sin x. I mean cos
Yes,
2x.
we're going to use cosine 2x equals sine 2x. Okay, that's what we're going to use. Cosine 2x equals sine 2x because they made the typing error here. I looked at the original question paper, okay, and that was written in 2015. I realized that it should not be minus, but should be an equal sign. Right, so in other words, this one is cosine 2x equals sine 2x, okay, because that is what the students wrote in 2015. Cosine 2x equals sine 2x. So this whole thing that is equal to 1/2 with the cosine outside just simplifies to cosine 2x equals sine 2x. Okay. And then what do we do with this? Right. Remember, we need to determine the general solution. It's not a specific or particular solution. It's a general solution. It's a general solution. So we proceed as follows. We proceed as follows. Okay, yeah, we're good. What do we do to solve this particular question? Because it is exactly this. So there are a couple of things we can do. The cosine becomes nicer. So I'm using the word nicer on purpose because it works beautifully. If you have an equation like this and it involves cosine and sine, it's easier to just work with the cosine than the sine because the sine is an odd function and it presents many cases, but the cosine just is in one step produces all the answers you need. Why? Because now when we have the sine, we can change the sine to the cosine. And then we can then write 90 degrees minus 2x like this. Right. Now, when you get this, then what we achieve here? We have 90 degrees minus 2x. And then what do we achieve? Right, we're able to then say that we have the cosine that appears on both sides. But because the cosine is an even function, it means that whenever you have 2x, it will actually therefore be equal to plus or minus 90 degrees minus 2x plus 360 degrees times k in z. K is an element of the integers. So you get therefore these two answers. At this point, you can write 2x is 90 degrees minus 2x plus 360 degrees by k in z. Okay. Now, we can deal with this one. Okay, we're dealing with, yeah, we can write or to look as if we are dealing with one case here. So we have 2x equals the negative 90 degrees minus 2x plus 360 degrees by k in z. Okay, so we continue. We continue. Right, so which means that we have 4x equals 90 degrees plus 360 degrees by k in z. Or, and then now you have 2x equals for the other part minus 90 degrees minus plus 2x, right, plus 360 degrees by k in z. Okay, we divide through by 4 here, getting x equals exactly, what is 90 degrees divided by 4? Right, it is 45 degrees out of 2. Can write 22.5. Right, so yeah, we'll get to that. Let us first things first, divide 360 by 4, and that gives us exactly 90 degrees. 90 degrees by k in z. Or, now we have 2x equals this. There's 2x, you bring 2x to the other side, it becomes 0 is minus 90 degrees plus 300. Okay, very strange thing. Very strange equation. Okay, right, because now it's saying 0 is equal to negative 90 plus something. I mean, it does not make sense, this. Okay, right, meaning that we're going to just deal with one case. So this one is not applicable. Okay, because it cannot be true that 0 is minus 90 degrees. Even if you can vary the values of k here, when k is 1, when k is 0, then it says 0 equals to minus 90. It can't be. Okay, so now we have 45 degrees divided by 2. You can write as 22.5. Right, 90 degrees by k in z. Okay, now we need to determine a general solution, so we're good. We'll be good. Any question here now? Anything to add, remove, or whatever? Anything to add,
So
remove? Yes.
I get confused with these questions when they say hence.
Yes, definitely. Up to now, the hence suggests the use of a previous
So
result. Yes.
exactly what must you do when you see that word hence?
Yes, when you see the word hence, you must look back. You must look at the at the at the question above, the result from above. Normally, the examiner says hence because they are trying to say, okay, sometimes they use the word hence or otherwise. Okay, because you see, normally when the examiner says hence or otherwise, it means you can do your own thing, you know. Like in this case, if we had not done that, a student would come here, cross multiply, and do all sorts of things here. Okay, which would also be correct. But because the examiner realized that, okay, if we can first deal with the inside here and just simplify this, then the whole question is going to be much easier. So the examiner said, okay, let me get the student to first simplify this, just prove that this equals something. Normally, when they say hence, they want you to use a result you proved. Okay, it takes us back to why do they ask you to prove things in physics and mathematics? Why? They ask you to prove things because they know that you're going to use the thing. Like in physics, if they say prove that the velocity is 2 meters per second, normally it's going to be used in the next question, and the examiner wants to come clean. The examiner wants to be fair to the students by saying prove, so that even if a student does not get that answer right, that is to be proven, at least they can get something from the next question, because they already know that they said prove that the answer is 2, so the answer must be 2. So, and they need to use that answer in the next question. When the examiner then says hence, they're saying use that answer from above. But if a student was not asked to prove, they would not know what the answer is. They would just assume it's their answer, maybe which was wrong. They made a mistake, and now they would lose all the marks in the question. So yeah, so the examiner says hence, and they say hence to use the previous result. But I must indicate that it's not the only way to do this particular question, but there are billions, but there are tons of ways to do this. Let's look at the next approach. Right, let's look at the next approach. The next approach is, okay, because they said general solution, in this case, we leave it in terms of K. Because they said general solution, so yeah, we leave it in terms of K. We don't, substitute the values of K there. But okay, now if we need to look at the general solution of this one, we have seen already that this equation is actually the following. Okay, I'm going to write a bit more steps here, just to make sure we get a bit more traction, but also we get a sense of the question. Right, we have cosine x and cosine 2x. You divide everything by cosine x plus the trigonometric sine of x equals 1/2. What is this? We have seen that we're to prove that sine 2x equals cosine 2x. We're to prove this. We had to prove this. We had to prove this. So now, we can do this differently. I mean, we can decide to do it differently. Okay, was it sine 2x equals cosine 2x, or the other way around? It was cosine 2x equals sine 2x. Okay, there's symmetry, but the cosine was first, so I just need to write it as it is, but doesn't matter. Right, so it was cosine first, so yeah. Okay, another student can do it differently. So it was cosine 2x equals sine 2x. So another student can do this question differently. I mean, we used what? We used here cosine, cosine. But you can make sine, sine. You can make it sine, sine, and the answer is going to be obtained. So now a student is going to make it sine, sine like what? Okay, let's look at this cosine and make it, we can make this cosine sine. So we can change the cosine, make it the sine of 90 degrees minus what? Minus 2x, which must be the same as sine 2x, like this. Okay, yeah, we can change cosine and make it sine, because 9 degrees minus is in the first quadrant where everything is positive. So this entity is positive. Why is this important? It is important because it's telling us that the sine of 2x is equal to a positive number. And now we can even write this thing as sine 2x, which is equal to the sine of 90 degrees minus 2x. Okay, what is all this stuff here? Okay, it is telling us that the sign equals something positive. So the sign equals something positive. We go back to the cast diagram and we say, in view of the cast diagram, we're going to work in which quadrants? Right, we're going to work in exactly the quadrants where the sign is positive. So where is the sign positive? In the first quadrant. Right, so in the first quadrant, then you're going to have exactly 2x is equal to 90 degrees minus 2x. Okay, just look at another way to do this question. Plus 360 degrees by k in z. The kid can do this question like that. Okay. And then now you can manipulate everything and add up. And let's add up everything. So now we have the 2x, you add the other 2x, getting 4x equals 90 degrees. 90 degrees plus 300 and 60 degrees by k in the integers. So now we divide 3 by 4, which is what we did. We get exactly 45 degrees out of 2, and we get 360 divided by 4 is actually 90 degrees by k in z. And this gives us, okay, 45 divided by 2 is 22.5. 90 degrees by k in z. K in z. We continue. Okay, we got one of the answers, but yeah, I mean, we look at one quadrant here because we look at the quadrant where the sign equals a positive. That is 90 minus, which is in the first quadrant. But also you can be able to deal with the following, right? So at this point, this angle is an angle in the first quadrant. But you can also deal with an angle in the second quadrant where the sign is positive, like this. So if you have the sine of 2x, which equals the sine of 90 degrees minus 2x. Okay, so we have the sine of 2x. Now, we can actually make these an angle in the second quadrant. So how do we make it an angle in the second quadrant? If we are sure, therefore, that this is a sort of an acute angle. Right, so we can also be in a position to then say this is a small angle, so we can write here the sine of 180 degrees minus this angle, minus 90 degrees minus 2x. We can try to do this. Because the 180 minus is in the second quadrant, and this 90 degrees minus is sort of an angle in the first quadrant. And therefore, 180 minus will take us to the second quadrant. Right, meaning we have 2x equals 180 degrees minus 90 degrees plus 2x plus 360 degrees by k in that. Right, but now we are back again to the Royal Rumble, and we're able to see that we have 2x minus 2x, it cancels out, and we again having the 0 equals 90 degrees, which is sort of the dilemma we ran into even when you use the cosine approach, and we're able to see that, hang on, we're getting this equation that says 0 is equal to 90 degrees, but these are never equal, meaning this is not applicable. So obviously, it takes us back to the fact that the solution is only 1, and is x equal to 22.5 degrees there. Any question, Neville? Right. Any question there, Neville?
No
Oh,
question.
okay, good. But now there's another kid who is way too smart. There's another kid who's way too smart, who's going to come and say, okay, but they said hence, and we already know that the cosine 2x is equal to sine 2x. The kid can come and say, but I can just do this easily. I can just divide. Yes, we can just do division. So the kid can come and then say, whenever you have cosine 2x equals sine 2x, you divide this one by cosine. Right, the student can divide by cosine 2x. Because the kid knows, therefore, the sine of the cosine is 10. Is 10 to x. Okay, the kid can divide like this because they can convert this whole thing to 10 to x. And the kid can be like, wow, this is now awesome. Because if ever you have 10 to x equals 1, then you can come and take the 10 to x equals 1. And what you do? Okay, now this is like the tangent is positive, so you back to the Gauss diagram, and you can use the tangent to do this. Okay, when is the tangent positive? Because the number 1 is a positive number. It's positive in the first, but also positive in the third. But now you need to, first things first, you get your reference angle, which is arctan 1, and arctan 1 equals what? Equals 45 degrees. Now, this gives us the 45 degrees at angle that sits exactly in that particular quadrant there. And that means that you'd have 2x is equal to, right, it is equal to 45 degrees plus the period of the tangent, which is 180 degrees by k in the integers. And we divide through by 2. And if we do, we get 45 degrees out of 2, 90 degrees by k in the integers. So yeah, another kid can do it like this. And therefore, this one is 22.5 degrees plus 90 degrees by k in z. Okay. Okay, what is the next thing? Okay, the next thing would be to then say, okay, we got this answer here, but is it the only answer? Obviously, you can try and reason this out in terms of other quadrants where the tangent itself is what? Is positive. In which other quadrant is it positive? So you would then say the tangent is positive in which other quadrants? It is also positive in the third. That's interesting. And taking you to 180 degrees plus 45, which is obviously a 225, right? And that would give you another possible answer, but very, very interesting result. But now we have got the main important result for this question, but a very interesting question though. Right, we've got the most important result which has been obtained using the other method. So yeah, we good and assorted. Okay, assorted. But yeah, it will be very interesting to explore this further in terms of what happens if, okay, I want to look at this other dimension. What happens if you are dealing with this? You are dealing with 10x equals 1, and you are then saying there is an angle in the third quadrant. Oh yeah. And then if you look at 180 degrees plus 45 degrees, plus, okay, this is very interesting, right? And then you have 180 degrees by k in the integers. Okay, we good? We good. So you'd say, therefore, that this solution and that are equivalent solutions. They're just the same solution, right? They're just the same solution. Why? Right, because this is 180 degrees plus the 180 degrees by k, and therefore it simplifies to exactly the same. So this 180 degrees plus, or you can still actually look at these as, because these are like multiples of that, so it's some 180 degrees by n, where n is an integer. So okay, with the 45 degrees. Okay, with the 45 degrees. But yeah, I want to demonstrate another view, because another student can be like, okay, but yeah, it's in two quadrants that the tangent is positive, but why only looking at the 45-degree angle in the first quadrant? Why don't we also consider 180 degrees plus, which is acceptable? Because now this is actually exactly 45 degrees plus. So this 180 plus 180 becomes 180 degrees by n in the integers. So divide through by 2, which means x is 22.5 plus 90 degrees by n in the integers. Okay, yeah. So we're good. Okay, so in other words, these two sort of be equivalent. So these two answers become equivalent. So somebody can be like, okay, yeah, so it doesn't matter. It's very interesting, but to be just equivalent, because the 180 degrees is going to be added to multiples of 180, getting other multiples of 180. So yeah, it's good. Can do it. Okay, but where is the n coming from? Right, where is the n coming from? Another student can ask. Okay, you have 2x equals 45 degrees from this, and then you have 180 and 180 here. 180 degrees, k plus 1, k in the integers. Right, so the n here is like, k plus 1, because this 180 and 180, you can add them up. taking out a common factor of 180 degrees here, and then you have k plus 1 in the parentheses. So these things become equivalent solutions anyway, and these are where the n's themselves here are integers. So n is an element of the set of integers, and we have the answer. Let's move on to the next thing. I believe this is pretty clear. Okay, we're good. Right, from the Mpumalanga province in 2015, the kids were asked this one. Let's check what the kids had to do in Mpumalanga. They had to calculate the value of values of x, where x is between -9 degrees and 270 degrees. If you have been given that the sine of, right, you have been given exactly that the sine of x is equal to cosine 2x minus 1. Okay, we need to solve, which means that, what is this? 1 minus 2 sine squared. 1 minus 2 sine squared x minus 1. And then what do we get? The 1 minus 1 is like a 0. Okay. And this is actually the sine of x equals -2 the sine squared x. Okay, we don't divide here. But now we transpose things, because if you divide it by side x, both sides, we're going to lose solutions. So we factor out. Okay, before we factor out, it can help some kids to just make sure they get the correct signs. Just collect terms on one side of the equation, and therefore you have 2 sine squared equals 0, meaning you have the sine of x we take out, 1 plus 2. The sine of x is naught. The sine of x is naught. Or the sine of x is -1/2. Okay, so we're good. We're good. Now, we need to determine the general solution, so there are a couple of things we need to do here. So now, which is 0, or the sine of x is -1/2. All right. Okay, now let's think together. Let's think together about this. At this point, what do we do with this? What do we do with this? When is the sine equal to 0? So yeah, we're going to look at the cast diagram for this one, and we're going to look at the cast diagram for this. Right, so look at the cast diagram for this, and we also have the cast diagram for this. Now, when is the sine 0? We said before the sine is 0 here, the sine is 0 there. Right, when is the sign negative? All right, the sign is negative in the third, is negative in the fourth. Right, meaning already we need to find the values of x in that. So normally, yeah, the solutions are not so many, so you can write the general solution part of it. But yeah, you need the reference angles, please, first. It makes the work much more accurate, and it makes us avoid lots of errors. So which means therefore we're going to have the reference angle, arcsine 0. What is arcsine 0? It's actually exactly 0 degrees. Okay, now we're going to find another reference angle for this part, which is exactly arcsine of the +1/2, which becomes exactly 30 degrees. Okay, good. Now, with the reference angle of this one here, you can write a couple of things. So you can write 0 degrees plus 360 degrees by k in the integers. Okay, 0, and then we can have 180 degrees plus 360 degrees by k in the integers. So now you have this one, 30 degrees reference angle here, but yeah, the sign is negative there, which means you have 180 degrees plus 30. And 180 degrees plus 30 plus 360 degrees by k in z. All right, so let's check here. Right, you're going to have 180 plus 30, which is 210. 360 by k in z. K in z. Okay. We also have x equals 360 degrees minus 30. 360 degrees by k in z. Which means 330. by k in z. So now we have 330 and then 210. Okay, we're good. We're good. Let's check this one. Let's check this one. All right, so now if we want 180 plus that, and then you have 210 plus that. And then we have 330. Okay, let's, yeah. Okay, let's write some answers here. What are actually the answers here? So you're going to have like this one of 180. If k is 0, you're going to get 180, which is between minus 90 and 270. So we can take x equals 180. You don't need to be showing lots of the steps here in terms of k equals this, k equals that. But you can show just to avoid errors. But also, because we already know the interval between minus 90 and 270, so right, when k equals 0, then we can get 180 degrees. When k equals 1, we can't take k equals 1 because it's 360 plus 180 is already more than 270 already. Just 360 alone. Then we say 360 plus 180. So it's way outside. Now, we need to think here. And can we add anything? If you put minus 1, k equals minus 1 is minus 360 plus 180, which is minus 180. It's also outside. So now, what values of k can you take here? It's only 0. That gives like 180, which is between there. The rest would actually be outside. So yeah, we're done with this one. Then we come to this one. When k equals 0, then we have x equals 210 degrees. 210 is between minus 90 and 270. When k equals minus 1 is minus 360 plus 210. What is minus 360 plus 210? Right, so this one here is actually a minus 150, but minus 150 is outside. Minus 150 is outside. So if you put minus 2, then it's going to be minus 720. It's way outside. Right, so you would get a solution that is most certainly outside there. Let's check. Right, so what other solution would we take? What other solution would we take? What other solution would we take? Okay, we think about this. I mean, we want to check if the solutions are all. Okay, now this one. Let's check this one. Okay, it's not all out because it's 330 degrees, but if you put k equals 1, then k equals 0. 0 by 360 is 0 plus 330. It's going to be 330. 330 is outside. But if you put minus 1, it's going to work. Because k equals minus 1, it's going to be minus 360 plus 330. So yeah, it's going to be x equals minus 30. Minus 30. So minus 30 is okay. Right, this we've dealt with this one, we've dealt with this one, we've dealt with this. Yeah, these are all the solutions. Any question, any suggestion? Maybe you think the solution we can get, we can like find still. Here in the Mpumalanga question.
No questions.
No question. Okay, we'll move to the next thing. Right, question from the Northwest. Right, now we need to simplify the following for just a good 7 marks. So just do that. Right, to simplify the following here, what do? We take the sign here and we use our cast diagram. Right, 0 degrees, 90, 180, 270, 360. Okay. Now, what do we do here? 180 minus x is in which quadrant? 180 minus is in the second quadrant, in which the sign is positive, and this takes us to side x. Now, this one is a negative angle, so the negative angles, I know that Neo deals with them beautifully. You can add to 360 like that. Okay, the 360 minus x is in the fourth quadrant, in which the tangent is what? The tangent is negative. So that this is minus sine x. Look now, it's cosine. Why is 450? Okay, can deal with 450. But 450 is the same as 360 degrees. 360 degrees plus what? Plus 90 plus x. Like that. So you have sine x, and then you have the cosine of. Okay, now let's come to this one. 360 minus 180 is 180. 180. 180 degrees plus x minus the tangent is sine x over cosine x, which is minus sine x. So now you have this one, which is a 360 plus 90. Now 360 plus 90 is exactly in the first. 360 is here, 360 plus 90 is in the first, where all are positive, so it's going to be 90 degrees plus x. Okay, yeah, there are different ways of doing it because you can do multiples of this and realize where the 45 is sitting. Okay, like the 450. Okay, this tells us that the 450 degrees is actually sitting like, it's the same as 90, you know? Right, because now if you have 360 and then you take 360, you say 360 degrees plus 90, you get 450. So 450 is here. 450 is here. Okay. We continue. So now let's do some cancellation here. Can simplify. This sign cancels, but leaving us with the minus one there. So now 180 plus is in the third quadrant, which the what? The tangent is positive, but the cosine is negative. Negative cosine x, and then we also have minus the sine of x over cosine x, like this. And then we divide everything by, okay, here we canceled everything, leaving us with a minus one. In which quadrant is 90 plus? Is in the second, where cosine is negative, but there's a cofunction change. Cosine is negative, but in the second quadrant, because 90 plus is in the second where cosine is negative, but it's the cofunction change of sine x. Right, we're good. Cosine cancels, which is plus sine x, which is plus sine x. And then which is plus here. And then this is exactly sine x. And this is 1. Any question, or anything we need to add, remove? Any suggestion? Maybe we can add something. Maybe there's a number that's missing. Okay, this question came from the Northwest. This
Why
question,
did you get
yes.
positive sign?
Come again?
The sign is positive, but oh, okay, it's fine. I see.
Right. Yeah, because obviously, I mean, there can be an error. There can be
The
something missing.
denominator is -1, negative sign x,
Yeah, the denominator
and
is
then
-1, and then if you multiply them, you get a plus. Is it correct?
the top one is negative.
Yes.
So why is it positive?
Okay, the top one is negative, negative. Right, so negative by negative.
Oh yeah, okay.
Okay, yeah. Because I'm trying to check if there's a mistake also. I mean, yeah. Because I'm just doing this question for the first time ever. But yeah, I'm just hoping that there's no error and like everything is okay. Right, but obviously we need to always check. We're human, and being human means that, you know, we can make mistakes. We are fallible beings. We continue to the next question. Continue to the next question. Northwest. consider the identity, prove this identity. Right, so to prove this identity, we actually let the left-hand side be sine x, sine 2x, 1 plus cosine x, cosine 2x. And then we have, okay, we need to prove that it is this, and yeah. Now, this is awesome. Maybe I can give you like, okay, yeah, let me give you a chance to share your thoughts. I'm not going to say you do everything, but let's talk about it. What would you do? What would you do here? Let's talk about it. Let's talk about it. What
Factorize.
you
It's
need to
to take out
factorize.
sine x.
You need to take out
Yes.
sine x. Okay, I need to take out sine x from the numerator. Very well done. So we have sine x plus, so the sine to x would be 2 sine x cosine x, all divided by. Okay, let's look at the denominator. What do we do in the denominator? Because there's a cosine to x in the denominator. So you can write it as what? It's 2 cosine squared x minus 1. Right, so that we factor out sine x from the numerator and we obtain 1 plus 2 cosine x. Okay, then you cancel out. So 2 cosine squared x. 1 plus 2 cosine x. You divide everything by the cosine x, which is 1 plus 2 cosine x. Right, and then now, what does this imply? It means the left would be, okay, the cosine cancels out, and we're left with sine x over cosine x, and this is actually the tangent of x, and this is the right-hand side. Okay, yeah. Anything about the question from the Northwest? Plus 5 marks. 2015 for the Northwest learners. Right. Sorry. What do you think? Anything to add or remove? Right. Anything
No.
to, nothing to add. Okay, good. We move on. Determine the values of x for which this identity is undefined. Back to the undefined. We're back to undefined. We're back to undefined. Okay, what do we do here? Okay, undefined means you consider both parts. So you're going to consider 1 plus cosine x, cosine 2x equals 0. And because we know that the 10x is sine x over what? Over cosine x. So we're going to say cosine x equals 0 for the 10 part. For the tangent part, the numerator is okay. It's always, those functions are always defined there. Those functions are always defined. Okay, the denominator is what you need to deal with. Need to solve for x here. Right, so let us solve for x. Now to solve for x here is 1 plus cosine x plus. We use 2 cosine squared minus 1 equals 0. This cancels. Cosine x2 cosine squared x minus, yeah, equals 0. Cosine x is a common factor. 1 plus 2 cosine x equals 0. Meaning cosine x equals 0 or the cosine x equals minus 1/2. Okay, yeah, okay. This tells us we already have cosine x here. So obviously we need to deal with, as a conclusion, we shall focus on cosine x equals 0 or cosine x equals minus 1/2. Okay, that's the thing. That's what we get. Right, so that would not just repeat. You solve for cosine x equals 0 here and there. Okay, it's going to just waste energy and time. In the exam, you're dealing with time constraints there. So you need to be very objective in the way you do your questions. But you see, if you look at this now, okay, we need to get the reference angle in each case. So the reference angle equals what? Equals r cosine 0, which is exactly what? 90 degrees. Okay, r cosine 0 equals exactly 90 degrees. Okay, the reference angle here, we have r cosine 1/2 equals 30 degrees, right? Now, okay, we have this. When is the cosine 0? We've already said that in the cast diagram, the cosine is 0 where? Okay, it is 0 on the y, right? And yeah, we get this. So which means that obviously, remember, we need to determine the values of x for each identity is undefined. All right, so yeah, 4 marks. Okay, 4 marks because it's a general solution. It's not specific because there's no interval that is stated. Right, so which means therefore you'd have x equals, you take the 90 degrees and then you add 360 degrees by k. K is that. Okay, now x equals. Okay, yeah. Okay, you have this. By k. Okay, yeah. What about this one? 30 degrees. Cosine negative. Cast rule. Okay, yeah. I wanted to write the word cast here. So again, if I put cast here, so cosine negative. Cosine negative. Cosine negative. When is cosine negative? Right. So it is because it is negative in the third, but also negative in the second quadrant. Okay. So now you'd have to say 180 degrees in the second quadrant, 180 degrees minus 30 plus 360 degrees by k in z, which is 150 degrees plus 360 degrees by k in z. Right, we're going to have another solution, which is which is going to be 180 degrees plus the 30 plus 360 degrees by k in z. This would tell us that x is actually also 210 plus 360 degrees by k in z. Right, so yeah. Okay, we've got two solutions. Okay, two solutions on this part here. For cosine equals minus 1/2, we got 150 in the second quadrant, 210 in the third quadrant. For this one, where the cosine is 0, we got it 90 degrees, but also at 270 degrees. So we sorted. Any question? And these two answers at 90 and 270. Okay. Any question? Anything to add, remove, or subtract?
No question.
No question. All right, good. Thanks. Now we move on. We move on. Right. So we have this one here. Gauteng 2015 June paper. Proof that the identity is true. Okay. It's like that one. Okay. Yeah, this one we're going to discuss it together because it's like the thing. Right. So now we need to let. Okay, you need to prove this, so you let the left-hand side, which is 1 minus cosine 2x minus sine x, which is sine 2x minus cosine x. Okay, good. So this is awesome, awesome, awesome. So in the numerator, we need Sine. So what identity am I going to use for this one? 1 minus 2 sine squared. Sine x we divide by 2 sine x cosine x minus cosine x. Okay, 1 minus 1 becomes 0, giving us 2 sine squared minus sine squared minus sine x, excuse. In the denominator, you can factor out cosine x. And this gives us 2 sine x minus 1. Here you can factor out sine x from the numerator. And if you do, you're left with 2 sine x minus 1. You divide by cosine x, 2 sine x minus 1. Okay, we're good. But what do we achieve? Which is exactly sine x cosine x equals 10x. So we're good. And therefore, this is the right-hand side. This is the right-hand side. So we're able to get the tangent of x. Any question, remark, anything to add, remove? Any suggestion? Any suggestion?
No.
No suggestion. All right, so we're good. Right. Right. Okay, let's move on to the next thing. Okay, we are good. We're here. For which values of x will the given for which values of x will the given expression be undefined? So now we're not looking at an equation, we're looking for that particular expression. So when is it undefined? Your take? Your take? Right. Right. Okay, yeah. What do you do there, Noah? What do you think? Okay.
You're gonna say
Yeah.
sine x minus cos x is 0. Is equal
Well
to
done.
0.
Yes. Yeah. Because an expression, so it's sin x minus cosine x equals 0. And this whole thing is 10x. So yeah. Okay. Well done, Noah. Sin x minus cosine x must be 0. Right. So. Right. Um. Right. Right. We continue. So what do we do? Right. Okay. Yeah. What do we do, Noah?
Oh, sorry.
Doesn't matter. Honestly, what do you think?
You say sine x equals cos x,
Yeah.
and then sine x divided by cos x.
So you can say sin x equals cosine x, right? And then you divide. Sin x, you divide by cosine x, which is cosine x.
Divided by cos x.
Yeah, we divide by cosine x. And then what we get?
tan x equals 1.
Yeah, and then what do we do? Right. You
And
get the
then
reference angle. Right. What is the reference angle for this?
it's 45.
45. Well done. Yeah, the reference angle. So, yeah, we did not get to the difficult questions today. Right. Arctan 1 is 45 degrees. So, what do we do?
And then you say quadrant 1.
Right. So we then say quadrant 1. Right. So because yeah, we say quadrant 1, but what other quadrant is there?
3.
Okay. Yes, quadrant 3. Well done. So quadrant 1, quadrant 3, because it's positive then. So which means x is 45 degrees plus 3 plus 180. Yeah. Because the period of the 10 is what? 180.
It's yes.
Yeah, 180 degrees by k in that. Okay, so you have the 180, the 45 there, but you also have 180 degrees plus what? Okay, but yeah, it becomes the same, these, for the tangent. So even if you take 180 plus 45 degrees plus, because 180 plus 45 takes you to the third, say 180 plus the reference angle, but you have this 180 by k, so which is 225, right, 180 degrees by k in z. Okay, let's check. So you'd have, okay, because they did not explain, they did not give the what? They did not give the thing, the domain. So yeah, we could, they did not give the domain. So they did not give the values of x for which the answers should lie. So we give the general solution. We give the general solution. Any question? No, anything to add or remove? Anything that
Nope.
you'd like to add? Okay, all right, or remove, we're good. Right, anything to add or remove? Okay, we'll move on to the next thing. Okay, we're good. Okay, now this one is the November paper. Show that sine x plus 1 equals cosine 2x can be written as this one. So you must show that we're doing 7.2. Sine x plus 1 is cosine 2x. Is actually the same as 2 sine x plus 1 equals 0. Okay? Show that this can be written like this. Right, so it's an awesome thing. So to show that, obviously we'd have to take the, can do it in green color to separate. What do we do now? Right, we have sine x plus 1 equals cosine 2x. What do we do?
Um,
I'm trying to engage you.
Cos 2x is 1 minus 2 sine squared
Well
x.
done.
And then
Right, so yes. Right, it's 1 minus 2 sine squared. Just wanted to get your view here. It's very, very healthy to always, discuss and get your opinion. So this one cancels out, and therefore we have actually our sine x plus 2, the sine squared, which equals 0, and then we have the sine x, open bracket, 1 plus 2 sine x, like this. Right, so what to achieve out of this? Okay, by the way, we just had to show that. So obviously, I mean, this thing can write it as what? Can write it as 2 sine x plus 1 sine x equals 0, which is exactly what we had to show. So yeah, nothing much, but yeah. Anything to add or subtract now, or anything to add or remove from this? Maybe if a suggestion that, okay, we can add a 1 there. We can make a change there. Right, so
no,
yeah.
thank you. It's
Okay,
fine.
thanks now. Okay, we move on to the next question. Okay. Hence or otherwise determine the general solution of that equation. Hence or otherwise determine the general solution of the equation. So you need to find the general solution of this one. Okay, now they said hence or otherwise. Okay, meaning you can do your own thing, but the examiner is saying, I'm giving you grace. I'm giving you a hint that hence, please use your answer from above. Yes, well, that is what we're going to do. Because we have been given sin x plus 1 equals cosine 2x, sin x plus 1 equals cosine 2x can be written like this. So given this now, we then write 2 sin x plus 1 sin x equals 0, which means sin x equals minus 1/2 or sin x equals 0. Right, as usual, we get our references, and we have our reference angle here, which is arcsine. Right, so we have here the arcsine of 1/2, which is what? 30 degrees. And then we have our reference angle for this other part, which is 0 degrees. 0 degrees. So now we are dealing with this particular cast diagram situation. And yeah, and now it's going to say quadrant. The sign is negative, and the sign is negative. Now it's going to say quadrant 3, quadrant 4. And here, the sign is 0. It's 0 here, it's 0 there. So yeah, we're good. But remember, we need to determine the general solution. So it's not all about getting the actual specific values. So we're going to have like, okay, we're going to start with this one, dealing with the other part, with the first part, we're in the third quadrant. So it's going to be x equals 180 degrees plus 30. 360. Okay, yeah. The sine is 360, has 360 degrees period. K Z. 210. 360. K in Z. Or fourth quadrant. Fourth quadrant. 360 degrees. Right. So 360 degrees minus 30. 360 degrees by K in Z. 330. 360. K in Z. Or, okay, let's see. We have 210 in the third, 330. It's an angle in the fourth. And then here now we have this side, this other one of sine 0 cos 0. So we have the reference angle 0, which means x equals 0 degrees plus. Now the period is 360 by K in Z. Right. Or x equals the other one, because you got 0 degrees there. But yeah, you have the other one, 180 degrees. Right. So 180 degrees plus 360 degrees by K. K is an element of Z. Right. So we're good, because yeah, the sun is 0 at 0 degrees here. It's also 0 at 80 degrees, but it's also 0 at 360 degrees. But 360 is taken care of by the fact that if K is 1 here, you're going to have 360 degrees there. So yeah, be safe. Right. Any question, anything to add, remove, any comment there, no?
No questions.
No question. Okay, thanks. Now let's see the next one. Right, we check the next question. Right, determine the general solution of the following. Correct to 1 decimal place. I know I've seen the time. I've seen the time that we are a little bit above the time. Right, so if you have 10x minus 1 divided by 2 is equal to -3. Right, correct to one decimal place. We cross multiply these, getting 10x minus 1 is minus 6. 10x, it becomes minus 5 if you add the 1. Right, and then we need to get our reference angle. And our reference angle is arctan 5. Taking the positive of this. Yeah, and we have a chance to launch our calculator here. This one is just going to be a bum jive. So now, if you look at this one, then you're going to have like octet. This is on what? It's in radians. You set up degrees, 3. Octan, 5. Okay, it becomes 78.69. 78.69 what? Degrees. 78.69 degrees. So you're getting exactly 78.69 degrees. All right. Now, this tells us, obviously, this sort of the reference angle, but the tangent itself is negative. So you're going to consider a couple of angles, which are namely x equals 100 and 80 degrees. Right. So for the, let's look at the cast diagram, and no one knows that. Okay, right. Where the tangent is negative, it is in the second and also in the fourth quadrants. The second quadrant is going to be 180 degrees minus 78.69 degrees plus 300. Plus 180 degrees because we're dealing with the tangent. Okay. We're dealing with the tangent function here. So we have exactly 180 degrees, multiples of 180 because of the period of the tangent, which is 180 degrees. 180 minus that. Okay, we're going to use a calculator to get that one. But also now in the fourth quadrant, it's going to be exactly 360 degrees minus 78.69 degrees plus 180 degrees by K in Z. Okay, we're going to get like 2 answers here. All right, and then here we're going to have plus 180 degrees by K. Okay. Okay, now you need to check if these are repeated. You see, the tangent has a small period of 180. So most of the times, like we saw before, the solutions become the same, even if you try to get as many solutions as possible, but you realize that the solutions themselves are sort of, start repeating because of the fact that the tangent has a period of 180 degrees, which is very small, smaller than the 360 of the others. So now you're going to have here 180 by K in Z. So what do we do here? Right. So now we have 180 78.69. 101.31. 101.31 degrees. 101.31 degrees. And let's do the other one. Let's do the other one. So we're going to do also this one. I want us to do also this 360. 360 minus 78.69 degrees, which is 281.31. Right, because if you say 360 minus 78.69 is 281.31, 281.31. 281.31 degrees. Yeah, so that gives us those answers, this one and that. Yeah, it gives us those two. Okay. Yeah, like we're saying, this might repeat. So in principle, then it is this one you can just leave out. Why? Okay, you can see that in some memos, they just leave this one out. and they just write this one. Because already if k equals 1, k equals 1 is 180 degrees plus 100 degrees. 101 degrees is already 281.31. So these things are the same. So you can just write one of them. So for the tangent, then you can just write the two angles, an angle in the first and the second quadrants. The angles that are in the third and the fourth, they sort of repeat any of those angles there. Okay, it's sort of the experience. Any question, any comment, remark there, Noah? Nothing?
No,
I
thank
know,
you.
yeah, I know we've been here for a while. Okay, because I can see the time is just above 10. I need to, right, you have to determine the general solution of this. I want to give you a small homework. Right, let me give a small homework. Yes,
Can we do 2008 higher grade,
this one.
June 32?
Okay,
Yes.
okay, good. All right, that's fine. Because I'm just looking at too many of the questions, but I'm seeing that our time is gone. So I'm just looking for a nicer question to give. Okay, now, right, because I know that I have all the questions from your paper. Right now, in this high grade paper, this is the one, right? Okay, good.
Yes.
Yeah, then I'm going to give you homework. Again, I was given exactly 8 marks. So you have actually 1/2 10x equals to sine 2x, which is 1/2 sine x over cosine x, which equals 2 sine x cosine x. All right, like this. You cross multiply this, which becomes exactly sine x equals 2 times 2 gives us 4 sine x cosine squared x. Okay, we take the sign out, which is 1 minus 4 cosine squared equals 0, which means sine x equals 0, or cosine squared x equals 1/4. Okay? Which means that sine x equals 0, or cosine squared x equals 1/2. So now, okay, when the sine is 0, let's get some reference angles here. Okay, but first, this cosine squared equals 1/4. Can apply the square root here and apply the square root on the right, but also put plus or minus. Which is plus or minus 1/2. Okay, so we have the reference angle, arc sine 0, which is 90 degrees, which is exactly 0, excuse. Arc sine 0 becomes exactly 0. Right, and then you'd have this one here. Okay, yeah. So now you'd have to get the angles that are between for this part, and then we shall go to the other part as well. Okay, for this one, when we're dealing with the angles between minus 90 and 180 degrees in that interval, so you would have therefore that we have 0 degrees plus the period, which is 360 degrees by k in the integers, so it's what we're getting. But also we have or x equals the other one, which would be 180 degrees plus 360 degrees by k in the integers. So we're interested in finding the solutions that are what? Right, we're interested in finding the solutions that are obviously also where the sign itself is. We said the sign is 0 here, it's 0 there at 0 degrees, but it's also 0 at 180 degrees. It's also 0 at 360 degrees, but the 360 is going to be obtained when k equals 1. So this is okay, takes care of that. And we have this particular case. Now, okay, for this part, what are we able to achieve? Right, we're able to achieve, therefore, that we have that x equals what? X equals 0 degrees. X equals what? X equals 180 degrees. Okay. Now, when k, now you can vary the k values here. Like when k is 0, 0.36 is 0 plus 0 degrees becomes 0 degrees. So yeah, okay. But if k is 1, is 360 degrees plus 0, which is 360 degrees. But 360 is outside. Okay, now we are done with this because if you can change the values of k, you can't get anything that, yeah, because when k is 2, it's going to be 720 degrees, which is way outside. Okay, when k is -1, it's going to be minus 360, which is way smaller, way outside as well. So when k is 0, then you're going to get 180 degrees. When k is 1, you get 360 plus that, which is like very large. When k is -1, you have minus 360 plus 180, which is minus 180. Okay, minus 180 is outside. Okay, we appear to be done here. And now we're dealing with this part. So this one is going to be 2 instances. And yeah, there's going to be a bit more work. Okay, you have cosine x is 1/2. Cosine x equals minus 1/2. Right. So now, okay, now let's get this one. Right, when the cosine is 1/2, what we get is the reference angle. Okay, let's do that. We have cosine x equals 1/2, or the cosine x equals minus 1/2, which means the reference angle is arc cosine of 1/2, and arc cosine of 1/2 is like 60 degrees. Okay, it's a reference angle for both of these. Okay, because if it's negative, then we take a positive reference angle. So for this part, when the cosine is positive in view of the cast diagram, right, so you'd have like 2 cast diagrams. Right, so the first cast diagram, it's the first one is for this and the next one is for that. So when cosine is positive, then we are in the first and the fourth, negative in the second and the third. Right, so now we're dealing with the positive one first. In the first, which means that you're going to have exactly 60 degrees plus the period, which is 360 degrees by k in z. Or you can have the other one, which is 360 degrees, and then you subtract that. 360 degrees minus 60 degrees plus 360 degrees by k in z. 360 minus, which is 300. Okay, so k in z. Okay, so yeah, we do 300. Okay, 60 degrees is in the first, and then 300 is in the fourth quadrant. Now we come to this one, the -1. Right, so you'd have here the reference angle is 60 as well. So this is going to be 180 degrees minus 60, because it's minus the reference angle to get to the second quadrant, but the period of the cosine is 360 degrees by k in z. Right, which means x is now 180 minus 60 is 120. 360 by k in z. Okay, or x equals, so you have, okay, yeah, it's minus there. That you have 180 degrees plus 60. So 180 degrees plus 60 degrees, and then 360 degrees by k in z, which is exactly 240 degrees plus 360 degrees by k in z. Okay, or x equals. Okay, so you have the 120 in the second, but there's also 240 in the third quadrant. So yeah, let us list some of the angles we need here. We're gonna list them in by changing the actual values of what? by changing the values of k. Okay, let's start with this one. Right, when k is 0, then we have 60 degrees. It's okay, because it's between minus 90 and 180. When k is 1, 360 plus 60, it's outside. When k is negative 1, it's minus 360 plus that is minus 300, it's outside. So yeah, I'll be down here. Let's come to this one. Yeah, when k is right, yeah, interesting. When k is 0, you have 300 degrees. We don't want it because it's outside. But when k is minus 1, it's going to be minus 60. It's going to be minus 60. All right. Okay. Okay, we're good. We're good. Now, okay, yeah. Okay, we are dealing with this one. Just checking here. So we're dealing with this one here. Minus 60 degrees. Okay, right. So the minus 60, okay, here. When k is minus 1, then we have minus 360 plus 300, which is minus 60. When k is 2, it's 720 plus 300. 720 is outside. This is the largest k is 180. So when k is minus 2, it's minus 720. Minus 720 is outside. So yeah, we come to this one now. So we dealt with this one, then we come to this one. When k is 0 with x equals 120, it's okay. When k is 1, it's 480 outside. When k is minus 1, it's minus 360 minus 120, minus 240, sort of. Okay, yeah, but it's outside. When k is 0, 240. When k is minus 1, minus 360 plus 240. What is minus 360 plus 240? It appears it's a minus 120. Yeah. But minus 120 is outside this. So, yeah. So, yeah, okay, we got those. But now let us get more. Because, okay, there are other solutions that we stated from this part here, this part, 0 and 180 degrees, 0 or 180 degrees. So we also have x equals 0 degrees, x equals 180 degrees. Okay. Yeah, it appears that we have done the most we can. Any question here, Noah? Anything else to add or remove?
No, thanks.
Okay, good. Right, because I can see our time. I know. I can see our time. I'm just looking for an exercise for you. Because it's like too many questions here. I just want to give you something that you need to try. And this one here. Okay, yeah, this is one question that you need to try. High grade 2009 paper. High grade 2009 paper, 8 marks. You need to try that one. Okay, yeah, there's a question I'm looking for. Okay, there are just too many of these questions. Please, Western Cape, preliminary. 5 marks, please try it. 2016 Western Cape preliminary, paper 2, question 6.2. F of x equals g of x. Determine the general solution. Please, that's a homework. So this one is a home activity. Right, it's a home activity. And then let's move on. KwaZulu, Natal, Gauteng preliminary. Okay, Gauteng preliminary paper 2. This one is your home activity. Okay, let's read it because I know that we have been here for more than 2 hours. Okay, right, but I want us to conclude with this one. Right, at this point, Gauteng preliminary, given sine theta cosine theta equals -1, okay, write down the maximum and minimum value of cosine beta, 1 mark. 5.5.2. Solve for theta, an element of 0 degrees to 270 degrees, and beta, an element of the interval from minus 180 to 90 degrees for 4 marks. Okay, this is the 2016 Gauteng preliminary paper. 2016 Gauteng preliminary paper. So yeah, 5.5.2 solve for theta between an element of the interval from 0 to 270 and beta, an element of the interval from minus 180 to 90. Write down the maximum and minimum value of cosine beta. Please try this one. Yeah, and then yeah, you have the whole week to try these questions, and then you can send your answers as WhatsApp messages, and then we can obviously take a look at those. All right, any question? This is enough for today. We have been here for like nearly 2 hours and 20 minutes, thereabout. Right. So yeah, it's 10:30 now. I know. We started at just nearly 8:10 in the morning. Right. So yeah, any question, anything to add, remove, or
Okay.
suggestion,
Thank
Noah?
you, sir.
Okay, thanks,
No,
Noah. All the
I
best.
don't have it.
All right.
Okay.
Okay, thanks, Noah. We'll talk then, and goodbye.
Okay. Bye.
Goodbye, Noah. Goodbye.